the field, and then typically you'll add up to a 1/64 split in the end, usually a 1/2 at the CO and then a 1/32 in the splitter cabinet. And then from that, you'll connect each of the individual premises. Although if you're going with a very short reach, sometimes you can do the split in the CO itself. Something that's becoming much more common is distributed split, or cascaded split, where you have different split ratio, where you have different amounts of splitting out in the field. You'll split a signal once and then split it again. Usually with again, you'll get to the similar kind of 1/64 split ratio, but maybe you'll do it by splitting 1/8 at the first splitter and splitting 1/8 at the second splitter. Then the final potential architecture, and there's actually a good article about this in the January ISE magazine, is the fiber tap or unbalanced split, where this is somewhat similar to a CATV architecture, where at the first drop point, you'll split off, you'll do a 90-10 split. 90% of the signal will continue down, and then 10% will be split to an individual customer. That architecture is becoming more common for rural FTTH, which is becoming more prominent with BEAD money and some of the other planning. Some of the customers that haven't been reached yet are in rural areas, and that might require a different kind of architecture. So this is a bit of an eye chart, and I'm not going to read it, but just highlights the pros and cons and typical uses of the different architectures. Home Run, or a P2P point-to-point network, has the advantage of near unlimited bandwidth. Change out the line card, and you can deliver as much bandwidth as the user wants. But it has the disadvantage of having a very high material cost, because you need an awful lot of fiber, and a high labor cost, because usually there's a lot of splicing involved. And it's actually not that common anymore for FTTH because of the expense. Centralized split is a good architecture. The advantage there is it's relatively low electronics cost, because few of your optical line terminal ports in the CO get wasted. You have one port that goes to a 1/32 split out in the field, and you connect that to 32 homes. You might leave some of those ports open in the splitter cabinet if people don't take the service, but you end up not wasting ports. Another advantage is easy maintenance and troubleshooting, because there's one spot where everything goes, and that's the splitter cabinet. Disadvantages: you're going to spend a little more on the cable, so you're going to need higher fiber count cable. One thing that a lot of municipalities, subdivisions, and the like have issues with is the cabinet itself. These are pretty big. They're the size of a large freezer, typically. And so where are you going to put that? Are you going to put that on the sidewalk? Or are you going to put that in someone's front lawn? There's often pushback on that for aesthetic reasons. And there's typically a lot of splicing involved, and splicing is expensive. Best used in high-density areas and where you have a relatively low expected take rate because of the efficiency in electronics. Anyway, the distributed split, which is again becoming more popular, the good news is you can use lower fiber count cables, and you don't need the cabinet. You can use, everything gets smaller with low fiber count cable. Your splitters can be housed in splice closures or pedestals, and so it's maybe aesthetically more pleasing. There's also less splicing involved because there's less fiber. The disadvantage is that potential higher electronics cost. You can strand OLT ports depending upon what your take rates are. And also the maintenance and troubleshooting is harder because you have to trace signal through the multiple splitter points. Most common use is medium to low density areas in suburban and rural areas. It's also a convenient architecture for MDUs, although I'm focused on outside plant in this talk. You can put the second split in the basement of an apartment building or on the premises of a, say, a townhouse development. And if you have a high take rate expected, then you'll use your electronics efficiently. The fiber tap or unbalanced split approach, the good part's very low fiber count cables, and therefore less expensive, and you can use very small footprint infrastructure when doing it. but it's probably the highest potential electronic cost per home. And it's the hardest troubleshooting because there's so many different split points where things are going on. And if you have to, it might take you a while to localize the break to repair. And where it's typically used is the low density urban areas, or, sorry, low density rural areas. Just to point out, typical cable selection for these distribution networks, centralized split, the general purpose loose tube type cables are most common. Flat ribbon may also be used, although typically in centralized split, your distribution cable will hit multiple splitter cabinets. And so the loose tube might be a little easier to work with because it's easier to do mid-span access. You can access one tube or two tubes at a time rather than doing the whole cable. And another thing we're seeing more of is micro cable that's jetted into microduct. And again, higher fiber counts. With the distributed split and fiber tap architectures, you can use lower fiber count cables. The general purpose are the micro cable. And one thing that you can even do if it's rural enough, or if it's a small enough area or rural area, is you can get into really small cables like a dry central tube loose fiber. What I'm showing here is a picture of a 24 fiber central tube cable that's very small, very robust, intended for direct burial. And that might be ideal if you're doing a fiber tap or a fairly low density distributed split area where you don't need a huge amount of fiber. So with that sort of quick review class of what the distribution network looks like, now on to drop to the subscriber. And if there's one thing to take away from this presentation today, it's that one size doesn't fit all. It depends upon the specific application, the specific area you're building, and what's important to you as a service provider. There's some value judgments to make about what the best way to reach the home is. These pictures are actually from my house. I'm in my home office today, speaking to you over an FTTH connection. This is the pole. It's in my neighbor's front yard with the power and CATV and actually two fiber to the home networks all running over it. And then this is the DMARC box and the cable running into my house that I'm speaking to you over right now. But the first question is, what's the right of way that you're going to use? Are you going to go aerial, buried, or in conduit? And then the next critical question is, how are you going to terminate these cables at both the distribution end and the subscriber end? And there's trade-offs associated with all of these, and the rest of this webinar will review them. So the first question is, what right-of-way? Are you going to go aerial, where the cable that's most commonly used is the dielectric flat drop, roughly 8 by 4.5 millimeters? Are you going to go direct buried, where you can put an armored drop in or a tonable drop in and hand plow it into somebody's yard? Or are you going to try to use a microduct type solution where you might use a blown fiber unit? It's not even a cable, it's just a protective tube for fibers and small plastic. These are all options depending upon the specific requirements of where you're installing cable. Each right-of-way has a different advantage and disadvantage. Aerial, and this was just emphasized by the most recent Fiber Broadband Association study that came out actually this month, aerial is going to be your lowest cost to build. Right now in the US, building aerial is less than half the cost of underground, based on the most recent Fiber Broadband Association study that came out last month. And it's going to be the fastest. There's nothing to dig. You can get the bucket truck out and go pretty fast. The disadvantages are aerial just isn't as reliable as an underground solution. You've got wind blowing over poles. You've got ice. There's probably going to be ice in the northeast U.S. today. Heavy wet snow from Pennsylvania to Boston. Trees fall, branches fall. That actually a tree fell in my front yard and took out my drop cable in 2020 or 2021. In more rural areas, you run in, or in suburban areas, you run into squirrels and birds that can damage the cables. And occasionally, you even have people taking a shot at a bird on a wire and causing shotgun damage. And then Aesthetics are sometimes a concern, especially in sort of planned subdivisions. People may not like the pole infrastructure. They may want everything buried because it looks nicer. Direct buried does have the advantages on once you get it deep enough, it's going to be pretty much resistant to weather, and the aesthetics are going to be better because everything's going to be hidden. It's going to be higher cost, and if you direct bury the cable, you're going to have some potential issues with burrowing animals like gophers and moles and the like, and also vulnerable to damage from dig-ups and cuts. Duct for FTTH, it's going to be the most reliable. You have 2 layers of protection between the fiber and the world, the jacket on the fiber itself and the duct. Another advantage of having a duct is you can do a rip and replace. You can pull out the cable that's in there and install another one by jetting or pulling or pushing. And of course, the aesthetics are good. But it's going to be the highest cost. There's 2 passes. First, you've got to put in the duct, and then you've got to come back in and put in the cable. In many cases, it may make the most sense to do duct if you're doing something that's truly greenfield, that you can put the duct in before the sod gets laid in a new subdivision, for example. And it is, just because it's reliable doesn't mean that it's bulletproof. It's still vulnerable to dig-ups. It's still potentially vulnerable to animal attack. Taking a different case by case, if you're going with aerial, what's your span length and what's your storm loading district? The picture on the left is the NESC heavy, medium, and light loading districts across North America. Again, the dielectric flat drop shown in the upper right is the most popular cable for aerial, and the reason for that, one of the reasons for that is that you can get a really long span length, up to 100 meters in NESC light, in a pretty compact package with this cable. And those span lengths, even in heavy, are typically enough to cover almost every possible use case for aerial installation. But there are options. There are round dielectric drops available that are smaller and don't have the stiffness and preferential bending of the flat drop. I've heard people tell me, I love the flat drop, it's almost indestructible, and people tell me I love the flat, or I hate the flat drop. It's too hard to bend, too hard to work with. So a round drop could be an option if you find that the stiffness of the flat drop is too much, but the span length isn't as high. It's going to be, depending upon the loading district, anywhere from 1/3 to 1/2 the span length. On the other hand, a round cable has the advantage of no preferential bend. Slack coils will be much smaller. Reels will be much smaller. Weight will be smaller. So if you are in a situation where your span lengths aren't that high, a round drop might be a legitimate option to consider. One of the reasons for the popularity of the dielectric flat drop is the wedge clamp shown on the right. That was originally developed for copper telephone drop, the so-called flat A-drop type copper drop, which actually my house had connected to the street when I moved in 2000. The clamp I happen to show is the Diamond Sachs wedge clamp, which is now made by PPC and has been around for over 50 years. And it's very reliable, very easy to use. People are familiar with it, and this flat drop is compatible with it. The round drop, you can't use the wedge type clamp. You'll have to go to something like the formed wire dead end clamp I show on the right. Those clamps are a little bit more expensive than the wedge clamp, but with reduction in material and the advantages of working with something round that's a little easier to bend, for an individual situation, that combination might be a better choice. Next, moving on to the buried right-of-way, questions you have to ask are, do you want to make sure that the cable is locatable or tonable, or do you want to go with an armored cable? There are choices again here. You certainly want to be able to find the thing after you put it in the ground. And I showed pictures of flags marking where the cables are and someone using a test device to locate where the cable is. before people like the guys in the lower left come in and dig up your yard to put in a sprinkler system or put in a new water line or that sort of thing. Another concern about merely using tonable or going with armored is animal attack. The picture I show in the sort of middle bottom, that's the Plains pocket gopher. Back when there was still the USDA could still do animal testing of cables, that was the reference animal that was used to test the rodent resistance of cables. They chew, they wouldn't eat the cable jacket, but they chew anything. If they don't chew, their teeth grow too much and they actually starve. So they have to chew to keep their teeth wearing down, like rabbits and other animals. If you're in an area where there's wildlife like that, you might consider a steel armor drop like the one on the lower right. It's bigger, it's heavier, but a piece of formed steel around the cable core is going to be the most robust thing against animal attack. But you might also go as an alternate. What's commonly used is you can bury a flat drop that has a copper wire that's attached to the main cable by a web. So if you're less concerned about animal attack, the copper wire could have lets you find the cable. And it also, that figure eight structure has the advantage of, with the dry armor drop, when you touch the house, they're going to have to bond and ground that cable. And that's going to take more time and cost more money. With the tonable drop, you simply peel you can peel the wire away by hand, snip it, and you don't have to bond and ground at the house. So it's a matter of which way you want to go. The dry armored, the armor drops are going to be most invulnerable to attack, but they're going to be bigger and heavier and require a little more labor to install. One thing we did to try to illustrate how tough these cables are is I went to the folks in the lab and said, let's test some of these guys to failure. Let's really destroy them and compare what the standards say to what these cables are capable of doing. So we did abusive test to failure of the crush resistance and impact resistance of typical buried drops. The first one we did was the dry armored round drop. The American National Standard for Drop Cable, ICEA 717, requires that you expose the cable to 100 Newton, which is about, I'm trying to do math in my head, about a 20-pound crushing load over, or a 200-pound crushing load over a 4-inch wide plate. You do that for a minute, and then you back off, drop the load to half that for 10 minutes, and then measure the signal loss. And the signal loss can't be more than 0.4 of a dB at 1550. So I said to the guys in the lab, let's test this sucker till it breaks. We were able to take it up while measuring attenuation up to 600 newtons per centimeter, which is 12 times the industry standard load with low attenuation. When we went up to 800, we broke a couple fibers. So it'll do 12x the industry standard. It won't do 16. But these are very tough little cables. And the standard, the standard's there. It sets a minimum baseline, but these cables can go well beyond that standard. And there's a picture of it. There's a little bit of imprint of the crush plate on the cable, but it's intact. The flat drop is even tougher. It's got two big rigid fiberglass strength members where the round drop has fiberglass yarn reinforcements, and the two strength members almost act like the supports on a bridge, the struts on a bridge carrying the load. So we were able to take this one up to 16 times the industry standard load with low attenuation, and we barely failed in one fiber at 20 times the industry standard load. And you can see from the picture with the flat drop, it barely even notices the crushing load is there. Then in the spirit of, let's see where these things fail, and also when you have a lab, it's kind of fun to try to break things. We did abusive impact testing of the same cables. The requirement is you hit the cable with impact energy of 2.9 Newton meters at 3 different spots, which is you drop a weight from a 1 meter height in 3 different spots. The jacket can't crack, split, or tear, and same attenuation requirement. So for the 12 fiber dry armored round drop, we were able to go 2x the industry standard load. We actually had attenuation at 2.5x the load that was unacceptable, and we went to about 3x the load. We actually broke some fibers. But, you know, it's taking a pretty severe impact event, as you can see in the picture in the lower right, and handling it. Where's my mouse? There we go. And again, the tonable flat drop is super tough with its 2 fiberglass rods next to the tube. There, we were able to go all the way up to 20 newtons per centimeter and get passing attenuation and no cracking of the jacket. At 5 newtons, you couldn't see that anything had happened. After 20, you'd see deformation of the jacket. We actually went all the way to 40 newtons per centimeter and had passing attenuation, but we started seeing jacket cracks beyond 20. And they weren't much, but it's you know, you could kind of look like a small split or tear after 20. So these are extremely tough cables if you put them in the ground. They do have decent resistance to, you know, they're not perfect, but they're going to be resistant to dig-ups to a certain extent. They're pretty strong little cables. The third right-of-way to consider is, are you going to put conduit in? Again, if you're putting it in, you kind of want to be able to find it so that when the guys come in to put in the new water line, they don't cut your cable and trigger a truck roll. There's 3 different ways that you can find your conduit. One is you can put in plain plastic conduit and then put a tone wire with your drop cable. Another thing that you can do is use a duct with a locating wire where the copper is embedded in the duct, although I have had people tell me that, you know, I'm not in the duct business and I'm not in the FTTH network business, but I have had people tell me that they have run into issues with the wire getting cut or also potentially breaking because the plastic stretches a lot more than the copper does, or the plastic and the copper stretch differently during installation, and sometimes it's possible to break it. And the other thing you could do is that you can throw in a tracer wire next to the duct. So those are all different options. It just depends upon what's most convenient for a given application. But if you put the wire with the drop cable, you know that it's with the fiber. Then once you have the conduit in ground, how are you going to get it in there, get the cable in there? One option is to push or pull. You put the fiber on a caddy. There's some actually mechanically powered caddies, and you can pull it with mule tape or a pull string, or if it's short enough, you can push it. And in those cases, I've heard of people pushing flat drop into conduit. It's got to be a big conduit to accommodate the flat drop, because the flat drop is 8.5 millimeters wide with the without the tone wire, and over 10 millimeters wide with the tone wire. The round drop you can push in a smaller duct, although maybe a little harder to push because it's not as stiff as the flat drop. But one thing that's very common in Europe and becoming slightly more common here in the U.S., if you're putting the duct in anyway, is to use jetting. You can use very small jetting machines that are tabletop type machines that come in a little carrying case, a little briefcase, and can run off very small air compressors. And you could jet in a round drop, the 5 millimeter-ish round drop, or you could even get to very small conduit, 5 by 3.5 or 7 by 4, and then jet in blown fiber units that can be as small as 2 millimeters, 2.4 millimeters, depending upon how much fiber you put in. If you're going to pull the cable, where's my mouse? Here we go. If you're going to pull the cable, these are again, pretty strong cables. You can put a pretty high load on these before you run into something that fails industry standards. Unlike the crush and impact, we don't design these to sort of beyond the standards. Here we design to just meeting the standards because over-design means more raw material and means higher cost for everybody. Again, the round drop and isn't quite as tough or doesn't quite have the strength of the flat drop. This is a plot of fiber strain versus tensile load for the two cables, where we essentially put it on a test bench and pull it, and we have a special instrument that can measure how much the fiber is stretched. The fiber is tested in our factory to 1% strain to make sure that every single inch of fiber is tested to that 1% strain. And then the recommendation from the industry is that the fiber strain at rated installation load be under 0.6%. And that gives a 40% safety margin against what the fiber has been screened to in the factory, because not everyone else out in the field is putting a dynamometer on the cable and measuring exactly how much force they're using. Sometimes they pull it a little harder than the recommendation. But in this case, for a hand pull or even a winch pull, these have a tremendous amount of strength for their small size. The round drop cable, you can pull it out to about 120 pounds of load before you hit the fiber strain limit. And the flat drop, by the nature of what it is, it's got much more strength member in it. The official rating for this cable is 300 pounds, but you can pull it out to about 350 before you hit the fiber strain limit. Or you can pull it, to about 325. If you're using a winch pull, a breakaway swivel that breaks if you exceed the rated load is a pretty good idea. If you're pulling by hand, you don't need to use a breakaway swivel because you're going to, even if you've got the biggest bodybuilder, weightlifter guys pulling the cable, they're not going to be able to pull it hard enough by hand to threaten the mechanical integrity of the cable or the fiber. Problem with my mouse. Give me a second. Okay. Last potential option is jetting. We have a jetting test track at our facility in Hyderabad, India, shown here, and a Plumataz Ultimaz E25 battery-powered small unit. And we have a number of different blown micro units that work in this application. Here's an example, actually, of something we did last week. Jetting performance of a 2.4 millimeter 24 fiber unit. We're going into 8.5 microduct. It uses a jacket that we developed and manufacture ourselves. And we were able to jet it 1,000 meters in 10.5 minutes with relatively low force. Final thing to consider, and I'll try to wrap this up quickly, how do you terminate these guys at the distribution end? And the questions you need to ask here are, what's your loss budget? What's labor availability like? Even now, with things a little slow in the industry, unemployment overall is pretty low. What's your CapEx budget and what's your project timeline? How fast do you need to go? If you're using fusion splicing or field connectorization, whether it's splice-on or mechanical connectors, any of the bulk cables we've talked about could work. But another option, extremely common, is factory connectorization. In some cases, people use the hardened connectors, like the OptiTap style, and there's some new hardened connectors on the market, and plug them into terminals that are installed on poles or in pedestals. And these are weatherized hardened connectors that you just screw in and don't need a separate enclosure. But in other cases, people use traditional SCAPCs and put them inside weatherized closures that seal. This is a picture of a 4.8 millimeter round drop with an SCAPC on it. We can directly mount that connector on that cable. And then how do you do it on the customer end? You ask the same questions about loss budget, labor availability, CapEx, and project timeline. Again, if you use fusion splicing or field connectorization, any of the bulk cables can work. Or you can use the hardened connector or the SCAPC or other types of indoor connectors. Any of those could work. What are the pros and cons? Fusion splicing is going to be the lowest attenuation and highest reliability, and you'll be able to do a precise cable length with minimum slack storage. But it's going to slow down your speed, it's going to raise your cost, and raises a concern with labor availability because fusion splicers are typically highly trained and highly paid. The advantage of biggest advantage of field connectorization is you can get a precise cable length with minimum slack storage. You still run into the kinds of problems you have when you have a connector. Slightly higher attenuation, although in most cases that higher attenuation won't threaten the system loss budget. Cleaning the connectors, there's a little more labor involved to terminate in the field. And if you're using a splice-on connector, you're still using a trained splicer to put the splice-on connector. Mechanical connector, you don't necessarily need that level of skill, although there is training involved. And then the third option is factory connectorization. That is your fastest deployment option. It's plug and play, and therefore it's going to be the lowest labor cost. However, if everything's factory connectorized, one big issue you run into is slack storage, or installers there, they've got the wrong length on the truck. They've got a 100-foot length of cable, and the cable needs to be 103 feet to fit the application. Or they put a 150-foot cable in, and they've got to figure out what to do with 47 feet of slack. In addition, connectors aren't free, so it's probably going to be a higher materials cost, especially because you're paying labor for someone to put that connector on in their factory. The last piece, how do you get into the house and connect to ONT? There are two options here. One that's most common is having a demarcation box. That's the demarcation box on the side of my house where it transitions to an indoor-outdoor cordage that goes through a window frame into the basement. But another thing that's common is cordage inside. It's a picture of a flat drop that has a 3mm riser-rated cordage inside. You can also do a round drop with a riser-rated cordage inside. You can use common tools to slit the jacket of the cable, whether the round or flat cable. This is the Jonard flat cable slitting tool, and expose the cord. And then you can just push the cord through the wall. And from a fire safety point of view, you're legal to bring it into the house as far as you want. Advantages and disadvantages here. The advantage of the demarc box is that biggest advantage is you can troubleshoot and repair the outdoor network without having to get inside the premises. And you also have an optimized cable for each job. You have an outside plant cable going into the demarc box and an indoor-outdoor or indoor cable coming out of the demarc box. The problem with it is you've got more stock keeping units. You've got to have both outside plant, inside cables. You've got to have the box itself. So there's just more parts to manage. The cordage inside approach, well, you've got your indoor cable and your outdoor cable together in one unit. But if there's troubleshooting required, you're probably going to have to get into the customer premises and have the customer be home in order to fix it. And also putting a cordage inside an outside plant cable just costs more than having regular fiber in there. And if you've got a really long length run, that might add up. So to summarize and give us some good time for the Q&A, considerations to think about when selecting a drop cable to the fiber to the home. First, what's your right-of-way? Are you going aerially? Are you burying it? Or are you going through conduit? For aerial cables, you need to consider span length and storm loading. For underground cables, you have to think about how are you going to find it and how rugged does it need to be for the specific environment. Termination, the options include fusion splicing in the field connectorization, and factory connectorization. You need to think about your system loss budget, what labor is available and what their skill level is, what your CapEx budget is, and what the project timeline is. Do you need to be fast or do you need to minimize costs? Those can be a trade-off. And then the final thing to consider is how do you actually get inside the home with the cable? Do you use a demarcation box and transition to an outdoor-indoor cable, or do you use a cable that has the inside plant cable inside? Final slide about HFCL. We do stand ready to be your low fiber count cable partner. We offer drop cable solutions for any right-of-way. All of the cables I showed pictures of are cables we make and offer in the North American market. We offer everything with the optional tone wire construction for location. We can offer the cables with 250 micron fiber for fusion splicing, 900 micron fiber for factory or field connectorization, or 3 millimeter cordage to go inside the house. We offer fiber counts all the way up to 24. We're willing to customize color, size, added tensile strength is something that we specialize in. We are focused on this business. We have 24 manufacturing lines across our 3 factories dedicated to making FTTH cables, world-class G657 and A1 and A2 type fibers, and world-class quality. We try to deliver value for our customers. So thanks all for your attention, and I'll throw it back to Joe to manage the Q&A.
Thank you, Peter. That was exceptional. I really appreciate it. We are going to open it up for Q&A. We do have plenty of questions down here, but I want to remind everyone to please write your questions in. There's still time, and we'll try to get to as many as we can. Some of you asked multiple questions, so we'll make sure we answer as many as we can here for Peter. Peter, I will start with this one here. And at any point, Peter, if you'd like to go through yourself and pick them out, if that's easy for you, let me know. But in the meantime, number 4 here, is there a direct buried or outdoor rated 2X fiber drop for open access solutions, MDU, garden style?
Yeah, we can do a number of things for that application. It's actually pretty common in Europe, and right now we have a much bigger presence in Europe than we do in the USA, and I do work with the European market. So we can offer, for regulatory reasons, all the drop cables in the UK are 4 fibers. And so for an open access network, we could do a drop solution where we put multiple cordages inside, essentially a breakout style cable. If you want to reach individual, so we can provision extra fibers for open access, or we can do things like breakout cables if you want multiple cables to reach multiple premises in a garden style.
Excellent. What is the maximum diameter of droop FOC, and how many minimum fibers in droop FOC?
Oh, I assume that means drop FOC. We don't make any. The biggest cable we make is a 9 millimeter 24 fiber armored cable for direct burial, and minimum is of course 1. That's most common in the U.S. In a lot of the rest of the world, we go with more than 1 fiber for regulatory requirements, or sometimes people just want to spare. So we do again everything from 2 to 9.5 and everything in between. So.
Okay, we have a question about what about butterfly drop cable versus round or flat cable?
That is a very good question. I did not talk about the butterfly drop. That is the world's drop cable. And actually, that's probably our largest drop product. We sell a lot of it in India. We sell a lot of it in the Middle East. We sell some in Africa. That's a cable that's typically 2 millimeter by 3 millimeter with aramid rod strength members and between 1 and 4 fibers embedded in a jacket. There's an indoor version that's 2 by 3 millimeter and an outdoor version that's roughly 5 by 2 millimeter with a messenger wire. And it's a great construction. It was originally developed in Japan. It's commonly used throughout East Asia, China, Thailand. It's the dominant drop cable in India. There's one problem with that cable. The span length is short, and that's why North America has been resistant to it. Even in a light loading, the span length just isn't that long. And so people look at it and they say, this is great, but I kind of need one cable that covers all of my applications. So it's it's fine for conduit. It's fine for very short span aerial. It's probably not robust enough for direct buried plowing. It's just not commonly used in North America because the span length, well, it's not commonly used in the U.S. or Canada because the span length isn't long enough for typical for every application, and it's not robust enough to be plowed in. But I noticed the person who's asking is from Mexico. I am familiar with those butterfly drops being used in Mexico, where the density of homes is maybe a little bit higher. It's a great choice if this, maybe the best choice if the aerial span length is low, like really low. That's just been the one knock on it for North America.
In a lot of rural areas, houses are located several spans or maybe more to individual hoses. The span lengths also exceed the maximum distance for flat drop and heavy loading areas. What are options other than placing strand and lashing a drop?
That is the most common. I mean, the question is, how many poles do you have and how far are they apart? But, you know, if it's NESC heavy and you are, you know, more than about 50 and the poles are more than about 40 meters apart, you're kind of stuck with strand and lashing. There is an option that we didn't talk about here, which is you can go to an ADSS type cable, a low fiber count ADSS, but it's different than what we showed here. The ADSS cables are a little bit bigger, but that is something that could be an option. It's going to be a little more costly, but you've got a unique application. So.
Excellent. And then someone asked, what do you see as the trend towards pulling the drop straight into the home versus terminating on an NID on the home?
I think the trend is to use the NID on the side of the house for the maintenance reason. Although many customers are pulling directly inside the house. So, you know, the nice part about the DMARC box is the technician can access it anytime in the event of something going wrong. And in fact, the benefit of the NID box or the DMARC box, I had a big old hickory tree that fell in my front yard 2 years ago and took out the drop cable, and also took out the power cable. And to the credit of my service provider, we had internet before we had power. They had run a new drop cable before the power company even showed up. But all they had to do was replace to the DMARC box. They didn't have to come into the house and run a new cable inside the house. They could just plug in, and if there had been just one cable, they would have had to get into the house, and it would have been a much more difficult troubleshooting or repair if it was just one cable coming straight into the house. So I think most people use the NID, but you know, it depends on the specific environment. And if you're coming buried, or if you're coming, you know, then maybe you're going to have less with the issues with trees falling and ice storms, and maybe the going direct into the house is a little more attractive.
Excellent. Well, Peter, if you were designing an FTTH network, what drop cable approach would you select?
Really, and you know, this is kind of a design philosophy that we try to apply for everything, is survey where you're building and see what the infrastructure already is. See if what you can do to take advantage of the infrastructure that's already there. Is aerial as reliable as buried? No, but if you've got poles available, use them. And just when you write your business case, plan that you're going to have some repair and truck rolls. It will cost you less to build a network up front. And, you know, yeah, you're going to have long-term maintenance costs. Build that into the plan. If it's a greenfield subdivision, put ducts in because you don't have to argue about aesthetics. You know, one thing I've heard of and seen is MSOs that have coax and conduit are leveraging that conduit to do the drops or to do fiber drops. They're essentially doing replacing or either replacing the coax with fiber or overbuilding with fiber to reach homes. So start with the infrastructure that you already have and work backwards from there.
Okay. Let's see. We have a question about what is the maximum span of butterfly drop FOC? We may have talked about that a little.
Yeah, I have to look that up, but it's on the order of, I think it's on the order of like 10 to 15 meters in an NASC heavy type application. And I think that's really the knock on it. I think in a light application where there's no ice, again, I have to look this up to be sure, but I think it's on the order of about 40 meters, my recollection, which, in a lot of the world is just fine. In the U.S., probably not good enough. So.
Well, Peter, is there anything else you want to add? Anything at all? Anything you'd like to say before we close this out as a final note?
Thanks everyone for your attention. This is the Homes Passed are nice, but Homes Connected get you paid. And if you need help with that, we'd be happy to help out and consult, do whatever we can. Thanks all for the attention.
Excellent. Well, it was such a pleasure having you with us today. So we really appreciate you spending time with us. Please continue to visit iscmag.com for information on upcoming webinars. Thank you everyone who came today for taking the time to invest in your professional development. And I hope you all have a wonderful afternoon.